a lot of people in this industry, they've never really standardized damage assessment processes. It can really vary from whichever party you're looking at in various roles. So C3 Group, we deal primarily with insurance disputes. And being the director of investigations, it's really been my goal throughout my entire career to really standardize our damage assessment process and also how we validate claims. And really what that's done for us and what I have confidence it'll do for any company that applies that, it'll be very successful in how you resolve claim disputes. What you'll oftentimes find is the opposing side, meaning the insurance carriers, oftentimes hire parties or contract third parties that aren't really privy to the policy, and therefore the definition of damage can vary. You have functional arguments, you have cosmetic arguments, and a lot of subjectivity really comes out of that. So if an insurance carrier hires an engineer, they might have a very different definition of what damage is than, let's say, the policy or manufacturer specifications. So the goal of this presentation really is to walk you through how we validate losses on the front end. This really applies to commercial losses and residential losses. So really, no matter the type of claim validation is equally important. So the purpose of this is going to be talking about components and damage assessment with a really big primary focus on claim validation. So let's begin. So our objectives here are to explain the critical role collateral damage and weather data have on claim validation. We're also going to be discussing the various flat roof systems and damage assessment process for each. And then we go further and separate out substrate types and damage assessment process. So those of you who have not really eased into the, gotten thrown into the commercial roofing kind of side of this industry, you'll notice there's a very big key difference between residential roof applications and commercial. And the biggest difference there is when you're looking at a commercial roof system, oftentimes the substrate can be the primary material that gets damaged before, let's say, the topmost membrane. So it kind of masks damage because of that. So if you're used to residential roof systems, you might be looking at the shingles, but you're not really paying attention to the felt, right? If you have a hailstorm or a hail loss, you're not saying, oh, the felt might be damaged, but the shingles are fine. That wouldn't be a thing. So that's something to get used to here, and we're going to be going over that in depth. But just so you know, that's why we break out systems and substrate types. And then at the end, we're going to be discussing some case studies just to walk you through some of the things we see every day. Obviously, no presentation out there is going to give you a bird's eye view of every single situation that you're going to see. You're going to see new things. So this is really just trying to bring awareness to all of us industry-wide so that we can address these efficiently. So starting with collateral damage, this really assists in determining hail size, hardness, volume, and really just basic claim validation. This is something that's widely overlooked by a lot of parties and even the insurance carriers. So a lot of times when we walk into these, we want to make sure we're validating the losses. A lot of the properties we come across, they've had numerous dates of loss, prior dates of loss. If a property is 20 years old, you might have hail occurred 10 years ago or 20 years ago, and you still see some of that evidence that occurred. So for us, we primarily look at spatter damage, damaged HVAC equipment, and dented soft metal surfaces. So when we're looking at spatter marks, it's really a good directionality indicator. A lot of the soft metals are good for also directionality, but also hail hardness and size. So a big thing in identifying collateral damage is, first, identifying red flags. I can guarantee you that going into an insurance dispute, the first thing an insurance carrier is going to look at, or a party that they contract out, such as an engineering firm, they're going to try to identify red flags. And if there are red flags and those are left unaddressed by you, that's a detriment to you and the process you're trying to pursue. So if you can identify those, address those, and if they're a red flag that can be overcome, great, but just identify when those occur. So this could be as simple as spatter marks being inconsistent with damage observed. So if you go and you see 2 to 3 inch hail damage on some of the vent caps or some of the HVAC, but you see limited spatter, maybe it's 1/8 inch spatter, it could be a red flag. And we'll get into this a little more, but if we have inconsistent damage between new and old condenser fins, if we have a rooftop unit like in that middle photo there, where we might have, great damage on that front unit, and on the same exposure on that unit behind it, no damage at all, it's a red flag. That damage on that first condenser unit might have been, or that rooftop unit might have been 10 years ago, and if we have a recent reported date of loss, this could be a red flag. And then also inconsistent soft metal damage. This is huge too, because if you see damage on some soft metals and not on others that might have been installed, let's say 5 years ago, and you have a date of loss that's a year old, that's also a red flag. So just identify these things because these are what the insurance carriers and their engineers are going to look at. Another thing is going to be condenser units or coil faces of rooftop units, really any kind of soft metal surface, honestly, but these are great because it's a vertical surface, so it gives you great directionality indicators, and then also it can kind of give you a good idea if you've had multiple days of loss. So looking at this, a lot of parties will come up on a roof and they'll say, oh, this thing is completely flattened, 1 date of loss, just hammered this coil. And a lot of times you have to look, in this coil specifically, it had been combed prior at some point. So that little triangular area there, we're trying to point out where someone in the past tried to comb that coil. And then they stopped. They might have torn the coil and they might have been like, oh, this isn't working. But they still combed that portion. And then another date of loss came behind that and further damaged that. So you had multiple dates of loss here. So again, just trying to convey the importance of identifying if multiple dates of losses have occurred. So spatter marks, this is a huge thing. A lot of people ask, how long does spatter last? Is spatter a indicator for hail size? And the answer is it depends. And yes, it is an indicator of hail size. So how long does spatter last? So just as an example, just to kind of dumb this down a little bit, let's talk about what is spatter first of all. So spatter is the oxidation of really any kind of mostly painted surface or anything with a chemical makeup. So if you look at bare galvanized metal or galvalume coated metal, you're oftentimes not going to see that chalky coating that appears. If you're a residential contractor, you probably regularly see aluminum gutters that are powder coated, and they kind of get that powderization to them when they've been sitting in the sun. Same thing, it's basically the paint just breaking down. So you'll notice this more on painted surfaces or anything with a chemical makeup. So if you're looking at a single ply roof system like EPDM that's dark in color, that'll oxidize and you'll find that it kind of gets chalky. If you kneel down on old EPDM, your knees will be black and you'll probably ruin your pants. So, a lot of that is just oxidation of something with a chemical makeup or a painted surface. So how long does it last? So just as an example, this spatter or this utility box was sitting in the sun for 12 years. It was installed in 2004. We had a storm date in June of 2016. So you can imagine you had 12 years of oxidation that had accrued on this utility box prior to that date of loss. Hail comes, removes 12 years of oxidation at this point. So right now we have spatter marks that have removed 12 years of oxidation. So now we see the contrast of no oxidation and 12 years of oxidation. That's why we see that. So 4 years after the date of loss, so this photo was actually taken 4 years after that hailstorm, and you can see that within those spatter marks, when they first occurred, they accrued now 4 years of oxidation. So you see that contrast still, right? Now we have what would be 16 years of oxidation on the areas outside of the hail impact areas, and then we have 4 years within. So the answer is this really depends. If this material had been sitting in the sun for 4 years, you would only have 4 years of oxidation accrual. And if you remove that, you might kind of reach that equilibrium where you're not going to be able to see this as evidently 2 or 3 years after the date of loss. So just be attentive to that, and also be aware if you're looking at building materials that don't oxidize as easily, such as masonry surfaces, bare metal, you're not going to see that oxidation kind of powderization coating. So just be aware of that. And then as far as hail size, do spatter marks indicate hail size? Yes, they do. So I don't know if any of you are familiar with someone named Jim Coons. He's a very prominent carrier engineer. And we honestly like Jim Coons in a lot of ways, and a lot of ways we don't, but he has published a lot of studies that are very beneficial to this trade. This is a study he did showing the correspondence between spatter mark diameter and hail diameter. And basically he concludes that the splash mark diameter is what he calls spatter marks are about half the diameter of the actual hailstone when it impacts a vertical panel at a 45-degree impact. So an example of this, we have a spatter mark here. We measure the width of the spatter mark, and then we basically multiply that by 2. So in this case, if we had a 1/4-inch spatter mark, this would be indicative of 1/2-inch hail. So there's a little close-up of view. We actually measure kind of the head of the spatter mark, not the trailing end below there. As far as weather data goes, so weather data is very, very important, but a lot of times people overuse it, and I'm going to kind of talk about how a lot of people target one thing. They find one thing that they like that kind of validates a loss, and they ignore the rest. And the right approach really is to select all of these sources of data, and if they align, it's great. If they don't align, it's a red flag. So don't just select what you want to kind of hear from one piece of data and just run with that. Really kind of like triangulate data pieces, and make sure that there's no inconsistencies there. Weather data is huge for that because a lot of it is algorithm based and it's weather data. No one's on site. You don't have a meteorologist sitting on site writing a report for you. They're doing it based on historical data, radar tracks, NextRad data, echo tops, things like that. So because of that, if you have great weather data but very poor on-site collateral indicators, red flag. Sometimes you'll have great on-site indicators and the weather data doesn't really align, and that happens too. So again, you're just looking at multiple data points. There are a lot of resources out there. You can pull things like hail trace. There's a lot of algorithm-based swath map services. We go to historical NextRad data tracks. You can pull that over the property. And then also NOAA actually has a lot of weather resources as well. So getting into roof systems here, we're going to be talking about built-up roofing, modified bitumen, EPDM, PVC, TPO, and SPF. Those of you who have come from the residential world, you're going to find kind of similarities with probably ModBit more than anything, modified bitumen, just because of its composition. So we'll kind of tie in residential roofing to that, maybe just to help you guys out a little bit. But really starting off here, so important considerations, and this is kind of going back to what I was discussing earlier on components must be individually assessed. The topmost layer, it might very well mask damage that exists below. So don't just look at a roof visually like you would a sloped shingled roof and say, oh, it's fine. And also, there's a notion out there that if water shedding capability is not reduced, it's not damaged. And that's not true. That's something you'll regularly hear insurance carrier engineers say. And really, they think that one of the only attributes of a roof is its water shedding capability. And that's just not true. So it kind of brings us back to what is damage. If you look up the dictionary definition of damage, it is direct physical harm caused to something in such a way as to impair its value, usefulness, or normal function. So if we apply that to every roof attribute, which is, sure, water shedding capability is one of those, but you also have fire rating, wind rating, thermal rating, UV protection. And if you have any kind of damage to any of these attributes, it's a reduction in serviceable life. It could affect the performance. It could affect numerous things. So we like to come into these and really look at each attribute and kind of just have a check mark in your head. Is it damaged? Is it not? Make it black and white and set up a standard in which you know when it crosses that threshold. So starting with built-up roofing, these are redundant ply systems. That's generally going to mean that there's a glass felt reinforcement, and it's basically just wedding cake layered between asphalt and sometimes on the older systems, coal tar. So this, they're very resilient, very reliable. That's mainly because they go back as early as the 1800s. So they've been out there for so long, and they can be very easily repaired. But there's a lot of considerations there. So we have a few variations here. So the variations on the left is where I'm starting, and we have built-up roofs with granulated cap sheets. So one of the things that you'll also see in this presentation is me pushing. You guys really need to core the roofs. You really need to do intrusive testing. You can't tell, similar to like a shingled roof, if you look at a shingled roof, you would never really know there's two layers, let's say, unless you peel up the eave edge or the rake edge. So similar in flat roofing, except there's no eave or rake edge you can just pull up generally, unless it's, maybe damaged by wind or something. But you need to cut these. So if it's a granulated cap sheet, you might think it's a ModBit roof, where in reality it's a built-up roof with just a granulated cap sheet. So it can appear to be a different system, and if you cut it, you'll know that. And then we also have built-up roofs with coating. So this will be some sort of UV protection. Generally, all manufacturers will require some sort of UV protectant. So that can come in the form of a granulated cap sheet, a coating such as aluminum or other elastomeric, whatever it is. And then you also have some built-ups with a flood coat or flood coats with pea gravel ballast impregnated into that. So again, just some sort of UV protection, some kind of surfacing. As far as number of plies, this can kind of be challenging, especially if you have a ballasted built-up roof system. But on some of the coated systems where the ply laps are actually exposed, it's pretty easy to tell. So every reinforcement lap width is 36 inches, roughly. So if we can tell the lap width and how much they're overlapped, we can generally tell how many plies there are. So if you have an 18-inch exposed lap, you know that that's a 2-ply, right? 36 inches divided by 2, you have 18-inch lap. Going on, if you have a 12-inch lap exposed, then you know it's a 3-ply. 9-inch lap exposed would be a 4-ply. So just kind of an easy way there. Damage assessment on these. So if you have a ballasted built-up roof, meaning there's rock sitting on the roof, it's not going to be likely that it's going to sustain field damage, right? Primary concern on a lot of these roof systems, and this is pretty consistent across the board, is going to be perimeter and curb flashings. The main reason for that, and we'll get into some designs and kind of visualize why that is in a second, but just know a lot of the times that's the most susceptible area. Secondary concern will be the field area. So if you have rock sitting on the roof, a lot of times these are not perfect installs. A lot of times there's maintenance issues. The rock might be scratched back or blown back in certain areas. So if the field is exposed, you want to assess that. But primary concern will be the perimeter and curb flashings. And then this, again, going to be consistent across all roof types. So perform intrusive testing. You really want to determine the condition of the substrate. This is especially true on built-up roof systems. Those of you who don't really know what I'm talking about when I say substrate, I'm talking about insulation boards or cover boards under that built-up roof system. So this could be a fiber board, it could be polyiso, whatever it is, but you want to assess and determine the condition of that. If you have a non-ballasted roof, built-up roof, meaning no rock is on the roof, obviously the field is very exposed, so you are likely to sustain field damage. Your primary concern here still, though, is the most susceptible areas, which could be unsupported areas at the perimeters or curb flashings. And then your secondary concern is the field area. This is going to sustain damage easier than ballasted systems. And then again, always perform intrusive testing. So here's a design spec basically showing the parapet transition. This is also applicable to curbs. So generally when you have built-ups or modified bitumen roof systems, you're going to have the transition between the field and vertical walls or curbs. There's going to be something called a cant strip. And over time, the membrane in that area, kind of outlined in red there, will pull away from that cant area. Especially with older roof systems, this might be very well supported at install, but 20 years down the road, sitting in the sun, especially in Colorado sun where I'm from, this is going to break down. So you're going to find an unsupported area there where there's just a little void there. So if hail impacts that, it's totally unsupported, and you're generally going to find damage there first. So here's an example kind of that. So we have a granulated flashing that extends up a parapet wall. You can see the ballast in the field there. This is a built-up roof. It was a 3-ply, and you can see the hail impact damage on the parapet transition flashing. So you can see that black mat kind of come through, right? Similar to shingles, you have the granules pop off. This had an aluminum coating over it as well for UV protection, but you really see that contrast. So easy hail damage, right? You see the one on the furthest right, right here. And that's basically a bruise and actually punctured the flashing. So your concern here, obviously, at this point would be, all right, I know it affected the flashings, right? But what else did it affect? Did it allow water to get into the system? Did the substrate absorb water? And that's where you'd go to intrusive testing and determine the condition of the substrate, which we'll get to later. But just know for now, this is kind of what you're looking at for built-up roof systems. If you don't have ballast sitting on the roof, this is a flood-coated roof. This is actually a coal tar pitch roof, which is an older type of tar used instead of modified asphalt on the newer types. And it actually popped off the flood coat. In this case, we had a bruise. You can see kind of where I have that circled area. It has like a little concentric ring where it impacted and just spalled off that flood coat. So here you kind of have to ask yourself, did it just damage the flood coat or did it damage the reinforcement ply? Sometimes what we'll do if we can't determine what it did there, we'll send this in for desaturation, which is basically where they use a vapor degreaser and they remove the asphalt or the coal tar pitch. And it just exposes the reinforcement layer. And you can tell if that was fractured or stressed, and it kind of might lead you to different repairs or replacement. Here's another example of a coated roof system, but this has an aluminum coating on it for UV protection. So this is very easy. That contrast is super easy to tell there. You can actually see the fiberglass reinforcement of the top ply of this 3-ply system. And you can also see the concentric fracturing around that area. So we had a bruise, we had concentric fracturing. What happens here a lot of times is you have engineers come up and they target the alligatoring, is what a lot of people refer it to. All this blistering on the surrounding flood coat. And they say, well, it's cracked there too. What's the difference? The difference is one's caused from an impact. One is caused from just sun degradation. So if you have an impact, it's spalling off that flood coat generally. It's bruising the material. And you have a concentric fracture extending from that point of impact. This is different from heat blistering where you a lot of times have just linear, jagged, random distributions of cracks. You know, it's very different. It's easy to determine the difference between the two. So moving on to modified bitumen, and again, we're going to go through substrates later because it's totally dependent upon substrate type. So built-ups, the damage we saw, we're going to go back to substrates. So just a reminder. Modified bitumen, this is what a lot of people will kind of identify with coming from shingles to mod bit. This is kind of the easiest roof system to transition to because it has a similar composition. Generally, it's granulated or sometimes it's granulated. It has a reinforcement mat and it's covered with modified asphalt on both sides. So similar composition there. It's commonly comprised of a base sheet and a reinforced cap sheet again. So kind of like felt and shingles. So you see the similarities there. Couple variations here. So we have ModBit with smooth roll cap sheets, some sort of UV protectant, right? It could be aluminum coating, it could be elastomeric coating, but some sort of UV protection there. So the one on the left there is a smooth roll ModBit. So that's it's a cap sheet and a base sheet, and they're bonded together. So it kind of looks like one thick layer, but that's actually a bonded or two bonded layers that are together. And then also we have ModBit with granulated cap sheets. Shingle guys, this is kind of what you're going to identify with. Both of these are direct to deck installations. So in these cases, you don't have a substrate, it's direct to deck. So just be aware of that. That can also come into play as far as the rigidness of the roof system goes. If you have a really rigid roof, it's very supported. If this was over something a little more spongy substrate type wise, you might have a little more impact, or impacts are likely to cause damage on those. So damage assessment on these, hail damage to the cap sheet is likely. It's exposed, there's not rock on it, right? It's very similar to shingles, you're not looking at the felt, you're looking at the top surface, right? Primary concern here is going to be the cap sheet, perimeter cants, and unsupported areas. So again, you're walking around the perimeter, you're trying to find the cant areas, the transitions, any unsupported areas. And then secondary concern still will be substrate. If you have random kind of, it's not consistent, you don't have 10 hits in a square, it's just kind of, let's say there's 20 on the roof on the edges, you still want to check the substrate. If it's soaked up water, you want to identify that condition has occurred, and you need, and that could sway it to a replacement. So just be aware of that. And then this is kind of a mouthful, but let's talk about kind of the different damages that ModBit can sustain. So those of you who have gone through insurance disputes with ModBit, you'll find that a lot of times they'll hire they'll contract an engineering firm to come out, and they'll take a sample, they'll desaturate it, and they'll say the water shedding capability is not reduced, and the reinforcement mat is not fractured, therefore not damaged. But it's important to realize that there is damage outside of those two definitions that can still constitute damage. So granule loss, that's UV protection, it's going to be damage. If you have fracturing of field-applied coatings like aluminum coatings or elastomeric, that is also a UV protectant and needs to be addressed if that's damaged. Bruising, that's stressing the material itself. It can be stretching the asphalt. It can be distorting the reinforcement. And there's a lot of bolt-ons even with shingle manufacturers out there that discuss how bruising is considered damage. You also have fracturing of the asphalt surrounding the reinforcement. So think of a reinforcement mat, and we'll get into the composition in a second to show you a visual of this. But the reinforcement mat is not a waterproofing component. It is a reinforcement component. So if you just had a reinforcement component on a roof, water would seep right through it. It relies on the asphalt surrounding that for the waterproofing attribute. So if you have fracturing of the asphalt, but the reinforcement's fine, your waterproofing, attribute might not be compromised at the time, but it's damaged to the point where it's reduced. It's lessened the thickness of that material. And also, if we have fracturing of the reinforcement itself. So again, I'm going to show you a visual of this, but we're always going to cut these. We want to find the substrate condition. So here's the composition of this. So you can see in the center there on the left-hand side, we have the fiberglass reinforcement, and then both sides of that reinforcement is surrounded with modified asphalt. It can be SPS, it can be APP, those of you familiar with the various types, and then some sort of UV protection. It could be reflective roof granules, it could be a fluid-applied field coating. So the composition there, you can just imagine that if hail struck this hard enough, you might have complete failure of the roof, it might puncture it, but likely hail is not always going to be so severe that it does that. You're going to have damage that is sustained up until that point that oftentimes is not addressed. On the right-hand side, you can see a fracturing of the reinforcement. That's what I'm talking about in severe cases where the reinforcement itself is actually compromised. So on these, generally, it's kind of similar to shingles in this case, except for the size of the test area. At C3 Gear, we generally don't do 10 by 10s on commercial roof systems. The reason being, on a sloped roof, you imagine you have shingles installed, right? They're small. If there's a repair method prescribed, you can follow that. You can replace maybe one or two shingles in a test square, potentially. Obviously, there's a lot of considerations there to think about. But on a flat roof system, you're thinking these courses are very, very long. They're 36 inches wide. If you have damage to that course, you can't really just cut out the parts that you want and just repair it. It'd be all patched up. So for that reason, we usually do a 2x2 test area on all commercial roof systems. This is 1/25th of a square. And in this 2x2, we'll draw it out. This also, because we cut these roofs, we don't want to cut a 10x10 back. That'd be insane. So we do a smaller test area. We circle areas of granulose in this case. You can see the M in that test area, and I'm identifying mechanical damage. So this was obviously a mechanical mark. It wasn't circular. There was no bruising. And the granulose was obviously a mechanical mark that caused it. So when we flip this over, we want to see basically what this did to the cap sheet. Is this just granulose? Is it just damage to a fluid-applied coating? And we can determine that by doing a cutout. So in this case, we did a little bit of smaller cutout because these were kind of sporadic on the roof system. This is a smooth roll mod bit cap sheet, so it has an aluminum coating on it. And the goal here is to separate the cap and base sheet, which oftentimes can be hard because you can have a torch down system where they actually bond with a torch, the cap sheet to the base sheet. Sometimes you have hot asphalt applied with a mop to bond those two together. Sometimes you have self-adhered versions as well. So it really depends, but if you can separate the base and cap sheet, the goal here is to see if you can find a corresponding fracture on the back side of the cap sheet that corresponds with the impact mark on the top. So we do the test area, we locate those impacts, we try to separate the base and cap sheet. In this case, we did, and we could see there was two very evident impacts. So this is going back to what kind of constitutes damage. And in this case, we had fracturing of the asphalt surrounding the reinforcement, but the reinforcement itself was intact. The roof was not leaking yet, but this is still reduction. This is still damage. Here's an example of a granulated modified bitumen cap sheet. So sometimes these can get tricky, and you'll see that going out there. You see varying insulations and various coatings. This one specifically had an elastomeric coating applied. So it's kind of hard to tell. It's very bright. If you're out in the sun, you better have sunglasses because it's very, very difficult to see what you're looking at. You can see that there's a little bit of dirt gathered in that top left impact mark at the top side there, that top circled area with chalk. And you see kind of dirt gathered in the area. And these areas were dimpled just slightly. And a lot of times what you'll find is dirt gathering in these low areas can indicate you have an impact that depressed that area downward. In this case, too, we had a very subtle star fracture, but what we did, we identified areas where there was dirt kind of gathering in these areas. It was very bright, so we had to look very closely. There was actually a little bit of a concentric fracture on the coating. This also had granules, so at some point maybe this got to be a little worn out, someone coated it. So you just adjust, right? You just think, all right, what's it going to do to a coating versus just a cap sheet with granules? So we're looking at that, and then when we identify that location, we're flipping that over, we're separating the base and cap sheet, and identifying and documenting that fracturing. If you submit this to an insurance carrier or an engineer, they cannot ignore this. If you show the process in which you're defining and you're going through every single time, you're going through a protocol. You're not just finding what looks to be damage and you're kind of making up this argument in your head. You're actually going through a process that's defined, and you'll find that engineers can really identify with that. So moving on to single-ply roof systems, and the remaining roof systems before substrates, we'll go into EPDM. So that's ethylene propylene diene monomer. What a mouthful. And it's an elastomeric synthetic rubber. So this can be reinforced or non-reinforced. So if you look at the left side, it's very smooth. And then on the right side, you can see that scrim in there. So that's a reinforced product. Generally, we'll assess these the same exact way. This is a thermoset roof system. A lot of single plies, you'll hear these different phrases go out, but just know it's one ply. So a lot of times if it's reinforced, you'll have that suspended between that ply, but it's still a one ply system. So different application methods here. So we have mechanically fastened, adhered in the middle, and then ballasted on the right-hand side. So what confuses a lot of people too is how to identify what's what. On the left-hand side, you can see the circular fastener plates on the seam of the EPDM, and then you can see the square fastener plates on the substrate. A lot of times people will walk up on these and see fastener plates and they say, oh, mechanically fastened. But a lot of times they'll mechanically fasten the substrate, as shown in the middle photo there, and that's a square fastener, and then they'll actually bond and adhere the EPDM together to itself, to the substrate, and then also at its seams. So you won't see fasteners at its seams. However, something to add a little more trickiness to this, sometimes there are hybrid systems. Sometimes you have adhered EPDM that might go 10 feet in from the perimeter, and it might be mechanically fastened in the field. Or you might have adhered parapet walls and a mechanically fastened field. So just look for those fasteners. My advice, if you can't tell still, run your foot across the membrane. If you can get it to ripple really easily, you can generally tell it's mechanically fastened. If you can't get much of a ripple when you do that, it's probably going to be adhered. On the right side, ballasted EPDM, probably one of the most resilient roof systems out there. So this isn't pea gravel ballast, this is usually river rock we're talking about. So you can imagine the impact resistance there. And also EPDM is extremely resilient. It has a good stretch to it. Generally, you'll see substrate damage. But if you have river rock sitting on that roof surface protecting that substrate and membrane, it's going to be very, very hard to damage. So I can say right off the top that ballasted EPDM is going to be the hardest roof system to get bought in insurance disputes unless you have very, very good facts, or the substrate might have absorbed water. But just know that. So damage assessment on these. So EPDM is unlikely to sustain punctures due to hail impacts. This is because of its resilience. It's a very stretchy material. And because of that, because you know that it's a very resilient material, your primary concern goes to the substrate. So you just think, what's the resilience of the product I'm looking at, and what should my primary focus here be? So in this case, substrate. And then secondary concern is the membrane. You don't want to write off the membrane. We've seen times where you might have underdriven fasteners where the fastener head is extruded above the roof, and you might have hail impact that area, and it just kind of pinches the membrane in between the fastener head and the hailstone, and it can actually just cause minor little fractures and tears in the membrane. We've seen that before. It's rare, but it does happen. So don't just completely write off the membrane. And then again, as you see on all of these, perform intrusive testing. You want to determine the condition of the substrate. So again, another example, a 2x2 test area, 1/25th of a square. In this case, kind of what I was going back to earlier on oxidation of the EPDM membrane. You can see that it removed the oxidation that accrued on that membrane. So what I'm doing in this case, I can see that spatter mark. I had good collateral damage, and I'm going down and I'm trying to feel the substrate condition. If it's depressing downward, I'm going to circle those areas. Those spatter marks are evident. I can see hail impacted area. And if I find a corresponding depression, before I even cut it, I'm going to identify that location. So I'm going to show you guys an example of kind of what this looks like. So you can see my finger going across that impact mark and kind of depressing downward. So I had a good spatter mark here, and I'm running my finger over that, and I feel that little depression. So just kind of showing, it's hard to explain, and hopefully this helps you, and hopefully you can see it okay on your end. But I'm just trying to find those depressions before I cut it. One thing that is important to note here, if you feel any substrate, you're going to feel seams. You're going to feel little depressions, depending on the substrate especially. If you can find correspondence between a spatter mark and a substrate, if you're identifying locations where there are depressions, you want to look for that correspondence because there's going to be little anomalies here and there on really any roof system. So going on with other single plies, we have PVC, polyvinyl chloride. This is a thermoplastic roof system. It's going to be heat welded, so its seams are going to be heat welded, and it has a crosshatch or a smooth texture. So depending on the manufacturer, it can vary here. Composition-wise, so you'll hear this is a very brittle roof system. A lot of people do not like PVC. A lot of people love PVC, but the fact is they rely on 25 to 35% plasticizer. And what that plasticizer does, it allows the membrane to flex and bend without fracturing. Unfortunately, over time, those break down. So if it's been sitting in the sun for a long time and it's gradually degrading, those plasticizers are going to migrate outward, and you're going to have a very brittle material. So because of that, hail impact damage on older systems, pretty easy to identify. You have a spatter mark in the center there, and you can see those concentric fractures extending from that point. So this is going to be different than thermal fracturing that you might see on corners where it's just linear. You have a point of impact, and you have a fracturing that's concentrically extending off of that. Application methods here. So we have also mechanically fastened, adhered, and there's actually some manufacturers that print ballast on the membrane. So Duralast does this, and it's just important to know that sometimes you'll run into this print where you might think it is ballasted EPDM, and it's not. So just be aware of that. And also, it's a good time to point out the vent on the right side that you see, they're vapor vents. And a lot of times that's an indicator that it's an overlay roof system, and you might have two roof layers. So even if you can't cut it at the time, if you're just walking it, it could just be something you note in your head. That's likely a second or even third roof layer. Let's skip there a little bit. So PVC damage assessment. So PVC is likely to become brittle and fracture from hail impacts. A lot of considerations here. If you have a brand new PVC membrane, those plasticizers that are added are still intact. So you might not have fracturing, in which case you would go to the substrate and you'd be like, all right, this is not a brittle material yet. It's brand new. I'm going to go look at the substrate. If it's an older material, your primary concern generally is going to be the membrane. Generally, that's what we see in Colorado. We run across new ones here and there, but a lot of times they've been sitting in the sun enough to where they become brittle. So in our experience, we look at the membrane first generally, but just know that it really depends on age. And then we're always going to cut them. We want to find out the substrate type and condition. Moving on to our other single ply. So we have TPO, thermoplastic polyolefin. And this is also going to be a thermoplastic roof system, and it's also heat welded. So TPO is going to be stable and flexible. It doesn't require plasticizer additives, and it does have a polyester reinforcement scrim, or sometimes referred to as a mesh, suspended between the ply. So similar kind of to the reinforced EPDM that we saw prior. Reinforced EPDM, PVC, and TPO generally are always going to have some sort of scrim. Application methods here. So we have mechanically fastened and on the left-hand side, adhered, and ballasted on the right. So I've actually never seen a ballasted TPO, but there are some drawings out there, and they do exist. So again, I've never seen it. I think it's rare in my opinion, but they are out there. So TPO assessment. When we're looking at these on newer TPOs, substrate damage is likely before membrane damage. So, all the variables out there is a little overwhelming at first, because with TPO, similar to PVC, some of the older TPO or the manufacturers that produce TPO at the start, sometimes those products failed, and they had kind of qualities that resembled PVC. So sometimes you'll look at a PVC or a TPO and think it's the other, and it's kind of hard to identify which. But just know some of the older TPOs, there's actually a Genflex TPO out there that broke down very similar to PVC, and it fractured in a similar way, and I'll show you a photo of that. But just know in general, TPO is very stable. So in this photo, we actually see, again, that dirt gather in those dimples. It's a very bright roof. It's hard to see. But in our test area, we notice these. And then a lot of times to document this, we'll put a straight edge or a ruler over that area, and we can see that depression. We're quantifying the extent of that depression. And here's that Genflex TPO I was talking about on the left-hand side. So you look at that and you see the scrim. It's not a smooth texture like a lot of modern-day TPO membranes. And it actually fractured like PVC. So you look at that and you just have to realize that it might be either or. And the best place to do is go to a boot jack or a termination bar or somewhere where you can find a manufacturer's stamp. The one on the right side, so this is a good example of a TPO membrane that's a great product. It's very stable, as we just went over. But it was over a substrate type that played a huge factor into the replacement of this roof. So in this case, we only had probably 8 of these impacts, and they were huge. And notice it's at a transition. It's out where there was a little void there. And I have a Tramex moisture meter. I'm putting that down, and automatically in my head, I'm like thinking, what is the substrate condition? Because this punctured the entire membrane. It tore the scrim. So this is big hail. This is about 2.5 inch, 3 inch hail. And in this case, we had water infiltration. Do not let another party come up here without the right tools or without cutting this material to tell you that this can be repaired just by heat welding a new membrane over these areas or a new curb flashing. So get ahead of that. If you have a Tramex moisture meter or you can cut these, do it. And in this case, it was a fiberboard substrate. The whole field of the roof had water, had a water-soaked membrane or a substrate type. So damage assessment on these. So TPO membranes are typically more resilient than their PVC counterparts. Obviously, we just discussed the variables there with both. It's age. Primary concern is going to be the substrate, though. Generally on modern day TPOs, you don't run into a lot of the older types because a lot of them have been replaced already because they've already failed. But in general, they're going to be very, very resilient, and your primary concern should generally be the substrate. Your secondary concern will be the membrane. We're also going to perform intrusive testing on these. So this is an example of a SPF roof. Some of you might have run into these, especially in warmer climates. This gets to be a very confusing roof type or roof coating for people because it can either be a mitigation attempt or it can be a roof system by itself. But let's just go over the damage first. So when we're looking at these, this is a foam product. It's spray foam. You know what hail is going to do to this. It's very compressible. So if you have a hail impact, it's going to fracture that. So on the left-hand side, we have an elastomeric top coat. So similar to other roof systems, we have a UV protectant. That can be a elastomeric top coat, or it can be granules embedded in a glue or adhesive they set when they cure the SPF. But in this case, we had elastomeric, and you can see the fracturing. On the right side, it's not uncommon to see installers where they put a reinforcement mesh in between the elastomeric top coats. And to me, this is kind of crazy because the repair of this material, this application doesn't really allow this material to be repaired. And we'll go over that right here. So one of the big manufacturers out there, which is Henry, they make Permax SPF. And you can look at their kind of protocol for repair or replace. And you go from light in degree of damage all the way down to severe. And you can see, even on severe, if you go all the way over, you see something called scarify. Scarify 3/4 of the roof surface, refoam, and coat. What are considerations there? What if the SPF is not even 3/4 of an inch thick? Or what if there's water in this system? There's so many things that they do not address. Or those of you not familiar with scarification, what it is basically like a lawnmower type device with a blade. You can set a depth and basically trim off a certain depth of that SPF. So what happens if you have on the right-hand side here a fabric embedded in that top coat? That scarification machine is going to jam up, so that's not going to work. So that's kind of, again, why I was going back to saying that's kind of weighing into the repairability factor of this. But again, there's no one-size-fits-all rule. You have to assess these and look at each component and say, what are the repair protocols of this? Do the manufacturer specs even apply or recommendations for repair? Can I even do that in this case? And SPF is huge for that. Another very important contributing factor for full replacement is water saturation. If you have a coating applied over an older roof system and there's a water-soaked substrate to the SPF, you don't want to coat over that and seal in all that moisture. So it's a huge consideration. So again, we just go back to having the right tools, see if there's water infiltration in the roof system. A lot of times we use Tramex moisture meters, but then also if there's a lot of water saturation and it becomes kind of a topic of dispute, we will oftentimes hire a third party to do what's called nuclear moisture surveys. And they come through and basically graph out all the water's location within that roof system. They grid it out and plot it. So it's super helpful and makes it very visual to see the extent of water infiltration. So special considerations, going back to, these can be either a system that's standalone that can be right on the deck, or they can be just a coating or a mitigation attempt. What oftentimes happens in Denver that we see, or climates around this area, is you have people come up and say, oh, your built-up roof is leaking, replacement is X. If I recoat it, it's Y. I think you should go with Y. And what they'll do is they'll usually scrape back the gravel ballast, for instance, and they'll just coat over the built-up. They just add another waterproofing layer. But that's not a standalone system. It's still very much relying on the underlying layers of the roof, especially for R value. You're retaining all the insulation and all that. So it gets very confusing in the estimation phase. But step one is this: just ask yourself, is it a system or is it just a coating over an underlying roof system? A big thing for that is look at the requirements for a standalone system. So if you look at the insulation specs for a system, they require 1-inch minimum coating of parapet walls. A lot of the edge metal and caulking has to be applied at termination joints. Just all of these things. So look at the specs for a system, and you can kind of backtrack and identify which one it actually is. Here's an example of that. We had SPF applied to this built-up, and you could actually see the granulated flashing of the older system's parapet transition visible. So we know that this never was intended to be a standalone system. It's still very much relying on the waterproofing of the underlying built-up roof's granulated flashing at the parapets. Estimation considerations here too. A lot of times people will really try to persuade you that no, this is an SPF roof. We want to bid it out for that, and say, okay, great. Well, go back and meet energy codes. Go back and meet specs for an actual standalone system. And a lot of times in our experience, it might actually even exceed the price of sometimes what these other systems would be. So you can go either way, but just be aware in your head what it is, what the application was intended for. So going into substrate types here. This is where we're going to be going into what you see when you cut these roofs. It doesn't matter what the roof is. It could be a built-up EPDM, PVC. But when we cut it, the substrate is the variable, right? Now, the membrane type or the roof type is not. So this is something that's very important and reasoning why you need to core. You might have an owner that says, I don't have leaking, I have no issues with my roof. And you core it, and it's saturated in between maybe two roof layers. You might have a TPO installed over a built-up, and the substrate between them is soaked. And the owner would never know that unless you cored. So it just kind of shows you really the need for intrusive testing, and especially cores. So this is an example. You recall the EPDM membrane where I drew out a 2x2 test area. This is what happens when I pull that back. And again, this could be EPDM, PVC, TPO, doesn't matter. But I'm feeling those depressions before I make the cut in a single ply roof system. And I pull that back, and I'm documenting those depressions. ISO is a faced product, meaning it's a paper-faced product on both sides. So it has a paper facer. That really just allows it to accept adhesive. It allows it to be flush right out of the factory. It's not all irregular. But what can happen is you can have fracturing of the facer sheet itself, or you can just have depression of the board itself, depression of the actual insulation. What does that do though? Is that damage? And in this case, we need to discuss also wind rating. So the membrane in this case is adhered to the ISO board. If you have fracturing of the facer sheet, which the membrane is adhered to, you're ruining that bond between the two. So that can affect the attribute of wind rating. And that's unlike a mechanically fastened system, which really acquires its wind rating from mechanical fasteners at the seams of the single ply. So this is a TPO. Again, we're looking at substrate types, not roof types. The assessment method is the same. So on this case, we actually could really easily document the facer sheet fractures on this ISO board because we're not destroying that evidence with the glue when we pull that membrane back. You'll notice in this case, going back, you can still see part of the facer on the right side intact. And it kind of was nice because we could identify areas where the facer was fractured and then areas where there was just depressions in the ISO itself. But in this case, we didn't have that. We don't have the insulation actually exposed. The facer is intact except for where hail hit. But the argument kind of becomes, what's our argument here? If we don't have an uplift argument, is this damage? What constitutes damage here? Is there any data that supports that? So again, what if it's mechanically attached and the sheet is fractured? Well, we go back to Jim Kuhn's reports, and he actually published, again, he's a carrier engineer. He wrote a report back in the day, I think this was the late 90s, and he did a test method showing what happens when you fracture the facer sheet of polyiso. And this report is specific to mechanical loading, meaning footfall, meaning you hit it with a mechanical tool upon installation. And he's talking about how it's a performance issue, but in this one report, there's one sentence where he talks about the kinetic energy that he generated was equivalent to the impact of a 2-inch hailstone. That's huge for us because we can now tie this report into hail losses. So in this report, he basically documents a certain percentage R value drop, which is thermal resistance. It's the measurement for that. And he documents upon 3 impacts of this polyiso, he had I think it was approximate 2% R value loss with 3 impacts. So that might not seem like a big deal, guys, but this is, again, where I get into a lot of the different opinions and subjectivity that comes with assessing claims, right? You might have an engineer come in, and they're weighing in economics for replacement. They're weighing in how much life is left in this roof system. On a policy perspective, we come into this and we think, all right, is there any reduction in serviceable life? Is there any reduction or damage to any roof attribute? Yes or no. That's all. Yes or no. It's not a maybe. It's not based on our opinion. And we use information like this to say, yes, there was a reduction. Great, it's damage. What do we do now? But this is huge because a lot of engineers will come out and just based on their opinion say, not damaged, water shedding capability not reduced. And in this case, we address this. We're like, well, that's funny because we had a carrier kind of prominent engineer author this report where he talks about R value loss. My recommendation here, if you really want to quantify R value loss and how important that is, think of a mall's energy bills. Think of, let's say the lifespan of the roof is 30 years, and you have 30 years of energy bills, whether it be heating or cooling, and you add all that together, and you take 2 or 3 or 4 or 8% of that figure. That is a huge loss. So quantified in means that people can easily understand. It's easy to look at this graph and be like, that's trivial, but just try to quantify that in different ways, and it's pretty successful if you do. Fiberboards. So going on to different substrate types, this is basically a wood pulp that has adhesive added, and it's just bonded together in one board. So this is generally unfaced, although it generally has a coating onto it, and we'll show you a picture of that. But it has the reason why, by the way, that I list rigid sound, slightly compressible by touch. If you can't cut these, and this goes back to ISO 2, if you feel it on ISO, you could actually hear the paper facer fracture. On this one, you could touch it, and you don't hear a facer sheet fracture. And if you can't cut it, you can generally push down on it and kind of get a good sense of what it is. So that's why I do that, by the way. These are very resilient because they don't have a facer. You really have to push hard on them to permanently depress them downward. They're kind of bouncy and they're kind of, they have a lot of resilience for impact. On the left-hand side, that's an example, again, of adhered EPDM over a fiberboard. So in this case, again, you can kind of see my wax crayon marks on the left-hand side there. A lot of times it's hard to chalk EPDM depending on how oxidized it is. So we use wax crayons sometimes, but we circled all of the depressions we felt prior to cutting, and all of those corresponded to spatter marks. So we're going through that process again. We pull that membrane back and we can see permanent depressions. I mean, you can see those very easily even if I didn't circle them. And then on the right side, we're just putting a scale next to that and showing that depressed the material. You can see kind of the deflection downward. You can see kind of the fibers kind of pop out a little bit and fracture. And here's what I'm talking about as far as on the left-hand side. These are primed generally right out of the factory. So that really allows them to accept adhesive for adhered applications like a lot of the single plies and the EPDM that we just saw. Something to be aware of here, though, when we pull this back, a lot of times fiberboards confuse people because it's such an irregular material anyway. It doesn't have a facer, and it's wood pulp, right? I mean, it's not going to be perfectly flat like a sheet of paper or a piece of wood or a piece of glass gypsum board or drywall, for instance. So when you feel that before you cut, you're going to feel a little irregularities, and a lot of people confuse that with hail impacts, depressions, and it's really not. It's tough. You have to really have very, very evident depressions like this if you want to pursue this. If you pull back the membrane, what can oftentimes happen too is you get wood pulp fibers that kind of pull off with the membrane, and then some stay on the fiberboard. Another example of that is here. So this was actually a very rigid fibrous board. There was also a cover board. It's kind of same type of material. And you have the same thing. You pull back the membrane with an adhered system. It's going to pull off some of those fibers with the membrane, some will stay on the board. But don't look at that and think too hard about it. I mean, this is a very common occurrence. Even on a new roof, if you were to pull back that membrane without any impact damage at all, it would probably look something like this. So you really need to look for something very, very defined. So moving on to perlite boards. So perlite boards is very similar to wood fiber boards, with the exception that they add perlite granules. It's a volcanic material. It actually just adds insulating qualities to the fiberboard. Just increases R value, basically. This can be soft or rigid. You see, like on the upper right, you see it's a very soft, fluffy material. Perlite's a very old building material, and they used to use it for tapered systems, tapered insulation systems. And a lot of times that was more the fluffy type. And then on the lower right, you have a very rigid perlite board. So this product absorbs water, similar to fiberboards. This actually is what I want to kind of go back to. You remember the built-up roof? We showed you the aluminum-coated granulated flashing. This was the substrate of that roof. The insured reported no leaking. We'll get into that in a minute. But it was soaked. And unless we did a cut, I mean, the built-up field was fine in this case. It was only the transitions. So unless we did a cut, unless we had the right tools, we'd never know that this really required replacement and not just a repair or replacement of the transition flashings. You can see on the bottom right, the reason why I show the picture of the deck. This is a double T structural concrete deck. This was actually seen going through the roof hatch. So a lot of times, just as a suggestion, if you can't cut it, look at the roof hatch, because a lot of times you can see unfinished areas where you can see the layering right there. In this case, they applied a flood coat of asphalt. They don't generally mechanically fasten structural concrete like this. So because there's no mechanical fasteners, they're relying on adhesives. In this case, it was an old roof. They used hot asphalt to bond that. But there's going to be waterproofing from that hot asphalt, right? That's sealing in the seams of the concrete. So if you have water infiltration, it might not even make its way inside the structure. So in this case, that's exactly what happened. But just to show you how important cutting is, generally going back to that built-up photo, we'll core right next to the hail impacts in the field as close as we can. In this case, the whole field was saturated, but... So another common substrate type is glass gypsum board. So this can be called Dinsdeck board, Secure Rock. There's a few different manufacturers. Georgia Pacific and USG are the top two probably. And this is a very rigid sound. It's almost wood-like, very compressible by touch. It sounds just like knocking on drywall, right? So extremely hard and very difficult to impact. So because it's so resilient, you kind of do the same thing. You feel this, and you have the benefit of this being a very flush material right out of the factory. Again, we have adhered EPDM on the left side, and before we cut it, we feel those depressions. They correspond with spatter marks. Hopefully it's starting to align there on what we're doing. And then when we pull that back, we can see those impacts. We see that it actually fractured this faced product. So unlike ISO, which is paper faced, this is actually going to be a fiberglass faced product. A lot of times, ISO can have a fiberglass component to it, but generally when you look at Dinsdeck or Secure Rock or other type of glass gypsum boards, they're going to have a fiberglass reinforcement. So we saw adhered systems similar to ISO. What about mechanically fastened systems? So this is generally what you're going to see. This is Dinsdeck. Obviously, they like to print their product name all over the board. Georgia Pacific makes this, and we could feel these impact marks, right? You can see the fiberglass face are a little easier here than on an adhered system. And we didn't tear anything apart when we pulled it back. So you can see that it's intact. We can still see the print of the logos. But where hail impacted, you can see the gypsum powderizing kind of pop through those fractures. And you can see the fracturing of the fiberglass reinforcement, the facer. So similar to ISO, though, what happens if on a mechanically fastened system, we don't have that uplift argument, right? There's no really thermal loss argument because it's not ISO, it's more of a coverboard type of material. What's our argument? So if you find that products don't have a lot of studies behind them, a lot of engineering reports, go to the manufacturer. So in this case, we went to Georgia Pacific, which was the manufacturer of this product. And we just asked them, what constitutes damage to your product? And they basically said if the fiberglass facers are damaged and the gypsum core is exposed, the answer is yes, it is damaged. We reached out to USG, who makes Secure Rock, basically the alternative product. And they said the same thing. These are designed to protect the roof from fire, hail, and wind uplift. We recommend replacing the product because we do not know if it'll maintain the wind uplift and fire properties. So huge there as well, right? We don't need to know the whys as to the manufacturer's stance on that. They made the product. They know that. I will say, in this case, it was funny because we had Haag Engineering come out, and they actually concluded that this was not damaged. It performed as intended. It protected the roof membrane from punctures. It was not leaking, performing as intended. Water shedding capability not reduced, therefore not damaged. But it's funny when we have that opinion based on subjectivity and opinion, and we have the manufacturer who made the product say it's damaged. We made the product, we know it's damaged, and it's damaged. So you can see who wins that argument there. Next is EPS, expanded polystyrene. So you guys have seen this all the time if you order a lot of Amazon packages like my family does. You see a lot of EPS, so it's just styrofoam basically. So it has a very dull sound, it's very compressible, but very resilient. So something about this, and I didn't really discuss this earlier, but ISO is closed cell foam. So that means that water does not absorb into the product. There's not open cells between all the insulation components where water can fill those voids. With expanded polystyrene, it's a little different and a little trickier because if you look at polystyrene or styrofoam, you'll see that there's little beads, and those beads are closed cell. But when they compress all this together, it'll leave little voids between those beads. So part of this is open cell, but it's considered a closed cell product. But just know there's a certain amount of water absorption that can occur with these. This is a good example of a ballasted EPDM roof, and again, why these are very difficult to get bought. Oftentimes they have they're over steel decks. They're usually commercial applications or concrete decks. They have closed cell, very resilient insulation types. EPDM is very resilient. It's very resistant to impacts. And then you have stone sitting on the roof. So you can imagine all of its components are very difficult to damage. And a lot of times what happens is you have seams be compromised over time through expansion, contraction. Like that is a real thing. So it does occur. But it causes leaking in sporadic areas. So every time we've come into these, a lot of times we'll see a common kind of reported thing of there's leaking in my building, right? The owner's like, oh, there's leaking. It happened after the data loss. And we might interview different tenants, and they'll be like, oh, it's been leaking for 30 years, and we're like, red flag, that doesn't look good. So again, these are just very difficult roof systems and difficult substrate types. So case study number 1, we're through substrate types. Again, we're going to be answering questions at the end. So if you have any, please jot them down, and we'll try our best to get to those. But case study number 1. So here's an example of great spatter marks, right? Great spatter throughout the property. But we had some contradictions here. We had kind of a lack of soft metal damage, and HVAC was actually pretty damaged. So what are we kind of thinking in our head here? Well, hail can vary in hardness, right? It could be like a slush ball, or it could be a solid ball of like clear ice, And a really good indicator for distinguishing between the two, spatter marks with a slush ball are going to be huge. But if you go to, soft metals, you might have no dents. So if there's not the density of a hailstone to cause dents to soft metals, it's probably not going to damage the roof surface. But in this case, the spatter was so big, and we felt just slight depressions in the substrate of this TPO membrane. We pulled that back, and you can see the facer's intact, the gypsum core is not exposed. So I'm just showing you examples of sometimes when weather data might suggest, like if you had a radar return, say, oh, this is 2-inch hail, it doesn't really tell you the hardness of the hail. That really concludes with on-site collateral indicators. So if that doesn't back the weather data, or maybe it was 2-inch hail, but it was just very soft, you just have to kind of walk yourself through that. So in this case, we wouldn't even pursue this roof system. We had good spatter, good weather data, good HVAC damage, so we pursued that. But the roof system was intact. It really did a good job of protecting itself. So Case study number 2. So this is something that you're going to see on the defect side. So you're going to see installation defects in products that just were installed incorrectly, and this is a case of that. So on this roof, we had 3 roof sections. We had a ballasted, built-up roof, EPDM over fiberboard, which we pursued because it had very good depressions. And then we had this side. So this side was about a 10 square area, and it just appeared a little bit different. We thought that we felt depressions. We did a 2x2 test area, and we wanted to cut this roof. So we marked there was 9 impact areas that we thought we could feel depression-wise in this board. And we cut it, and we see this substrate. So this is an EPS product. So this is going to be a plastic-faced EPS product, and it's generally meant for overlay roof systems. And that was the case here, but just showing you kind of what we felt. We felt these just minor depressions in this product. And we look at that and we say, well, the facer's still intact. You know, it's kind of difficult. Like, I don't know if we could really stand behind that. I mean, it really looks like the other areas surrounding this, but I think this is what we felt. And hail probably causes, but it didn't really do anything. We cored it, and you can see just what I was talking about. This was an overlay roof system. So a lot of times EPS products, some of them are about a 1/4 inch to 1/2 inch thick, and they have a plastic facer on one side or both, or varying facer types. And it's really just meant to fill in the voids of the ballast they can't remove on the built-up to just allow a smooth, like just consistent surface for that EPDM membrane or whatever they're overlaying it with. What was difficult about this was it had a foil facer on the bottom side. So this is for thermal reflectivity. There's a few qualities for it, but you can see it's fractured, but it's fractured from the rock, right? I mean, that's the kind of the point of it. It was sitting on a built-up, and it fractured it. What was difficult about this for us is that this product, it says dark colored membrane silver side up. So you can tell that they installed it wrong. They put the foil facer side down instead of up. If this would have been installed correctly, we likely would have had hail impacts that fractured the facer sheet of the foil facer. And in turn, we probably could have pursued that. But just showing you never will see the same thing over and over. You see maybe the same products, but they're arranged in different ways. They're installed incorrectly or very correctly where they just are resilient. You know, you have so many variables there. So just be aware of that. Case study number 3. So this was a commercial property in Fort Collins, Colorado. It was 60 mil, which is the thickness of an adhered EPDM roof system. You can see very evident spatter marks on the surface there. This is a Carlisle system. You can actually see the millage thickness right here. So that's common with EPDM. You can see 45, 60, 90, 80, whatever the manufacturer came out with. So we looked at the insurance carriers for assessment. This is very common with commercial adjusters. They know sloped roofing, they know shingles. You know, anyone can walk up on a shingled roof or even a mod bit roof and say, oh, granule loss, bruising, got it, hail. But on EPDM, it's different, and you could tell just the lack of knowledge on the insurance adjuster's side on this. So metal roofing, they paid for that, right? Easy stuff. Rubber roof, it's EPDM. They just called it rubber roof, and they put in elastomeric roof coating, small patch, just 20. I highly doubt, first of all, that there was any fractures to this roof. I didn't find any, but they just paid for 20, just kind of, took it off the top of their head and just put 20 in. But elastomeric, I mean, it's not even a coated roof. So this is very common. You'll see weird repairs outlined in insurance carrier scopes. So collateral damage-wise and weather data, great. They aligned. There's no question that large hail, 2.5 inch hail hit this property. So dented cap flashing, dented metals. They already paid for a lot of that. Some of the signage was damaged as well. Storefront anodized aluminum window frames were also dented. This is very difficult to do unless you have very large diameter hail. Same thing that we did at 2x2 test area. We see when we cut this, it's kind of hard to tell from this angle in the glare, but we see the oxidation marks. We circle those. You can see my finger kind of mark and remove oxidation across the membrane there on the kind of the left-hand side of that cut on the corner where the razor blade is right there. And that's me and my finger just feeling those indentations, and then I'm circling. So going back to that video, you see kind of the process there. And then this is showing the picture we showed you earlier of ISO and an adhered system, but I'm circling the areas that I identified prior to cutting. This was actually beneficial because part of the facer was intact and part of it pulled off with the membrane. So you can see the lower right hit there. You can see the facer fracture, and then you go where there's no facer and it pulled off with the membrane, and you can see depressions and the same thing. Something to notice here too that's worth mentioning, when you have adhered systems, installers they're not perfect, right? They don't install this perfect, consistent layer of adhesive between the ISO and the membrane. So because of that, it might be a little thicker in the center of this area, and the facer on the bottom and the top hand sides might have not had as much adhesive. So you had some pull off with the membrane, some stay on the board. So just kind of pointing that out, you're going to see that. Again, just a straight edge across the ISO board showing you how to quantify those depressions. And when we arrived, they actually retained a engineer. It was PT&C LWG. They're now actually in Vista is what they're known as. And we provided them engineering studies before we went on site. And you could tell even the engineer, he's like, I might have to do a little research on this. I just need to wrap my head around it. I see what you're saying. But so right when we got back to the office, we submitted these reports, which were engineering reports and done in a lab, done by very credible engineers. Some might argue that with Jim Coons, but great reports, right? And he responded to that very well. So this is probably one of the first reports we received where they didn't talk about just the water shedding capability. So they were talking about how there was no direct physical damage to the EPDM membrane, but there was damage to the underlying insulation board and the adherence of the insulation board to the EPDM membrane. So this was huge because they're not just talking about water shedding capability. And this just proved to us that, all right, we just need to provide them the right data. These people aren't perfect. They're people and they have lack of knowledge just like everyone, right? So if we have that knowledge and we share that in a correct way, in a professional and respectful way, you find great outcomes with this.